All right, we're moving on to solving equations by factoring, and we're working with these quadratics. Yes, these x squares. Sometimes they're x cubes, and you guys have been rock stars with factoring. And let's go ahead and talk about different ways that we're going to solve. So lesson 512, we're working on solving equations by factoring. And our essential question is, can you use factoring in solving polynomials equations? So the only difference that we have right now is when we have an equation, notice we have what? Good, we have this equal sign right here. That equal sign, now notice this one's already factored for us, so they were so kind to do that for us. But what that equal sign is doing is saying, hey, anything times 0, so if this whole binomial equaled 0, this whole binomial equaled 0, because of multiplication, this times this would equal 0, because 0 times anything is 0. If this whole binomial is equal to 0, this whole binomial is equal to 0, it would also equal 0. So notice what we did is I just set each binomial equal to 0, and like good old school solving, Algebra 1 solving, I subtract 2, x is equal to negative 2. So notice when x plus 2 is equal to 0, x is equal to negative 2. And when x minus 5 is equal to 0, we're going to add 5 to each side. X is equal to 5. So we have two solutions here, negative 2 and positive 5. So sometimes they're not kind. We always have to factor first. And if it's not factored for us, we're going to factor. So this one was kind. They factored for us. So remember, I'm going to set each side. This binomial, x minus 3, is equal to 0. And this binomial, x plus 4, is equal to 0. And now I'm going to solve. To solve this one, I have to do the opposite. So x equals 3. To solve this one, I have to do the opposite. So x equals negative 4. So my two solutions, now let me write these down because sometimes they call these solutions. Sometimes they call these roots. That's a new word for us. Sometimes we refer to these as x-intercepts because if I was to put this into a graph, this is where it would touch the x-axis. And sometimes they call these zeros. 4 different names for one thing. But I'm just going to write x equals 3, x equals negative 4, and I'm going to start looking for these 4 words that we just talked about. All right, moving on to example 3. Example 3, it's the same kit and caboodle, but now notice I have 3. Well, I know this isn't a binomial, but 6 times what gives me 0? Well, that what would be 0? 6 times 0 gives me 0. b plus 5 is equal to 0. When I subtract 5 to each side, b will equal negative 5. b plus 2 is equal to 0. When I subtract 2 to each side, b is equal to negative 2. So notice I not only have 2 solutions, but I have 3. Now, is it going to get harder? Yeah, it's going to get a little tougher where we're going to actually have to factor ourselves. If we notice the pattern, everything was equal to 0. So for example 4, it is not equal to 0. So in order to make this equal to 0, I am going to bring that 80 over by subtracting it. It's a positive 80, so I'm going to subtract it. Now, I have to go ahead and factor out that 5. When I take a 5 out, I have z squared minus 16 is equal to 0. And I can continue to factor z plus 4 and z minus 4 is equal to 0. And don't forget about that 5. Sometimes a letter or variable will come out with it. Now, in this case, because of that 5, if I was to divide that over to the other side, wouldn't it just be obsolete? 0 divided by 5, isn't that just 0? So I really just have to solve for these two. Because of my lack of space, I'm going to write those over here. Z plus 4 is equal to 0, and Z minus 4 is equal to 0. So when I subtract, I get Z is equal to negative 4. And when I add, I get Z is equal to 4. Two answers. And notice it was a Z squared. So sometimes that's going to be helping us. Sometimes there will be a double root, but we can get through this. All right, we're going to do one more because this one's a little bit tougher. First things first, is it equal to 0? Not at all. I got to get it there. So in order to make it equal to 0, I have to do what with that 10? It's a positive 10, so I have to subtract it over. Well, this one has an A term. First times last is negative 60. The factors of negative 60 that add up to be 11. Well, probably not 1 and 60. Not 2 and 30. 3 and 20. 4 and 15. Ding, ding, ding. Because they are actually going to subtract, because one has to be negative, one has to be positive. So let's talk about what one has to be negative. If it's a positive 11, the 15 has to be positive, and the 4 has to be negative. So I'm going to use 4 terms, because last time I did not. 6n squared. So remember, I'm replacing this 11n with that negative 4n, and that positive 15n minus 10. Anytime I have 4 terms, I'm going to cut it in half. What can I take out of the first half? 2n, and I have 3n minus 2. What can I take out of the second half? It looks like I could take out a 5, and I have 3n minus 2. And again, all of this is equal to 0. So I'm going to combine it over here. 2n plus 5 times, I took the floaters, 3n minus 2, and all of this is equal to 0. All right, got to keep going. I know if I set this binomial up and make it equal to 0, I can solve. And n was equal to negative 5 halves. And if I set this one up and make it equal to 0, I can add 2. 3n equals 2, divide by 3. It looks like n equals 2/3, and n also equals negative 5 halves. Great job.